guys, welcome to my channel. Can you imagine if I really did that? Welcome ladies, gentlemen, the non-binary, and people who identify as sea cucumbers. Not judging. Welcome to the physics battle station. Today I wanted to make a quick video. Editing is going to take 4 hours. Today I wanted to make a quick video about rotation, revolution, and how they relate to speed. And then we're also going to watch a clip from Big Bang Theory and see if their math is correct, so that'll be fun. So let's get started. First up is rotation. Rotation. Yay! Stop that. Rotation is defined as something that is oscillating around an axis within itself. So this coffee cup would be rotating around an axis going straight through the middle of it, and that would mean that it is rotating as opposed to revolving, which would be around my head, but more on that later. Example of rotation, here we go. Power drill, turn it on, and it rotates around an axis that goes directly through the middle of the axle. Another example, little life hack here. A couple years ago, my wife asked me to clean, well, I offered to clean the baking dish, the little like things you make muffins in. A little muffin, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you put the muffins into them. But cleaning them out is annoying. I gotta stop looking at myself, by the way, and look at the camera. So what I did was, I took a little scrubber, I cut off the end of it, and then all you do now is put it into the end of the drill, lock it up, and then clean in no time. Yeah, baby. So that's rotation. Rotating around the center axis going through something. Rotation. Revolution, on the other hand, is when something is revolving, try not to say rotate, revolving around an axis which is outside of the body that's rotating. So in rotation you had the axis going right through the center. In revolution you have the axis on the outside. So in the instance of this thing, if you want to spin it, hope it doesn't kill anybody. So if you want to spin this, you can see that the axis of rotation is near my fingers, but not near the object itself. The object being this weird looking polyurethane disc. Stop it. Yeah, that I found in the workshop. So that's revolutions. So how do they relate to Earth? Well, think of rotation as a day. So the Earth rotates around an axis going right through the center of it, and that the time it takes to rotate once all the way around is 1 day, or 24 hours. It's actually 23 and change, but we rounded up to 24 hours. Revolution, on the other hand, is when this thing is going around an axis outside of itself. So this should already look to you like the Earth going around the sun. So when the axis is outside of it, like the sun, the Earth is going to rotate around it. So what is revolution? Revolution is like a year. So rotation is a lot like a day, and revolution is a lot like a year when you're talking about the Earth. This is actually a soccer ball, it's not the Earth. You get the idea. Hey, whoa, whoa! Hey, quick note, sorry to interrupt. The Earth is not actually a perfect sphere. It's this thing called an oblate spheroid. An oblate spheroid is because it spins, the top and bottom push in, and the sides, 3 girls, hair everywhere. The top and bottom push in, and the sides push out. It's not like this, it's not Earth, it doesn't look like this, but it's a little bit because it spins. You can picture the sides coming out and the top and bottom going in. So, oblate spheroid. Sorry to interrupt, back to your program. So let's make sure you got this straight with a couple more examples. Ready? Rotation.
Oh, snap.
See that? It's the middle of the ball right there. Just as you was on top, just like that, as you saw before. Try to balance it, just like that.
Revolution. I'm getting dizzy just watching.
Because if it was fast, I would be freaking out.
Hey, say hi.
Hi.
Hello.
This is Sue High. Sue High. You know how high
I'll show you. Ready? It's that high.
Yeah,
It's really high.
Not drop your phone, Daddy.
Oh, we're going down slowly. We're going down. I'm yelling timber.
Okay.
So with all of that said, let's do a quick practice calculation. Two of them actually. Rotation speed of Earth and revolution speed of Earth. Let's start with rotation. As you know from the triangle, draw it up over here. V goes at the top, my head in the way. Still getting used to this. And then D and T over here. So velocity is up top, and D is on the bottom, and T is on the bottom right. Right? No, just kidding. Were you paying attention? It's actually DST, remember? Or DVT. Daylight saving time. Okay. So, to find the rotation speed, we're looking for the speed. You're going to be looking for speed, which is D over T. So speed is equal to the distance over the time. Rotation speed of Earth. First we need, what is the circumference of Earth? So what is the circumference of Earth? Like how far around? How far is it around the equator about? So, Alexa, what is the circumference of the Earth?
Earth's equatorial circumference is 24,900 miles.
So according to Alexa, the distance around the equator is 24,900 miles. Now, what is the time it takes to rotate once completely around? Well, that would be a day, wouldn't it? So, how many hours? I should actually put units here. Miles. And this would be 24 hours. See how the 24s line up so nicely? When you do this, you're going to find, this is the calculator section, so you divide 24,900 divided by 24. That'll give you miles per hour. And the answer is 1,037.5 miles per hour. Miles, hours per. So it's a little over 1,000 miles per hour. A little bit over 1,000 miles per hour. So you can just kind of memorize 1,000 miles per hour for how fast the Earth is rotating, and you should be pretty good to go. Next! Next up, we got the calculation for revolution speed of Earth. Now we're talking about the Earth orbiting around the Sun. Okay. Do I have to work on my lighting? So the revolution speed of the Earth is going to be very similar. S is equal to distance over time. This time, the distance is going to be how far it orbits around the Sun. Not just somebody standing at the surface of the Earth doing one rotation, but how long it takes to go around, how far and how long it takes to go around the Sun. So for time, it's going to be very easy. It's 1 year. We're going to automatically change that to 365.25 days. Because eventually you want this in miles per hour. We'll figure it out. Actually, we eventually want it in miles per second. I'll explain that during the Big Bang piece. But we'll just do days for now. And then for the distance, it's going to be a little bit tricky. Alexa, help us out. Alexa, how far does the Earth go in 1 year?
This might answer your question. Earth's average distance from the Sun is 93 million miles.
Huh. So instead of simply telling us what the distance is that Earth travels in a single year around the Sun, she gave us the radius. or it gave us the radius, or they gave us the radius. I'm not sure what the gender of Alexa is. Don't want to assume. So 93 million miles for R for the average distance from the sun to the Earth. Now you might think average distance, why am I not choosing the letter D? Because if you think about it, the distance from the sun to the Earth is actually a radius because it travels around in an orbit around the sun to give us the year. But lucky for all of us, the circumference formula is very, very simple. So it's 2 pi r, and r is that 93 million miles. Super easy. There you go. I'll plug it in for you. 2 times pi times 93 million divided by 365.25 gives you a big number, but we're just going to take that number and we're going to round it a little bit to make things easier. So I get rid of this and go 1,600,000. Now watch your units. We did this in miles, and the bottom is days. So this is miles per day. That's how fast it is in miles per day. But we're kind of interested in miles per hour, so we can compare these two. So how do you fix that? Really quite simple. You need to take this miles per day and divide it by the number of hours in a day, which is 24. So let's do that. If you plug that into a calculator, as I did here, 1,600,000 divided by 24 gives you a whole lot of satanic numbers. 66,666 miles per hour. So about 66,000 miles per hour is what we're hauling at right now around the sun. Pretty crazy. Why don't we feel that? More on that later. Now, for the problem that we're going to have in a little bit, I want this in miles per second. I can't tell you why yet. It's a secret. You'll see. Miles per second. How do you do that? You divide it by 60 to get it in miles per minute, and you divide it by 60 again to get it in miles per second. When you do that, you come out with about 18 miles per second. Can you see that? 18 miles per second, right there. So that'll be important later, and I'll reference that a little bit later. So I know that was a lot of math, but I just wanted to show you that number, this number, and this one, because we're going to use that for the Big Bang Theory episode that I'm going to show you in a second. All right, let's go.
Anyway, I was thinking more of a biosocial exploration with a neurochemical overlay.
Wait, are you asking me out?
I was going to characterize it as the modification of our colleague/friendship paradigm with the addition of a date-like component, but we don't need to quibble over terminology.
What sort of experiment would you propose?
There is a generally accepted pattern in this area. I would pick you up, take you to a restaurant, then we would see a movie, probably a romantic comedy featuring the talents of Hugh Grant or Sandra Bullock.
Interesting. And would you agree that the primary way we would evaluate either the success or failure of the date would be based on the biochemical reaction during the goodnight kiss?
Heart rate, pheromones, etc., yes.
Well, why don't we just stipulate that the date goes well and move to the key variable?
You mean kiss you now?
Yes.
Can you define the parameters of the kiss?
Closed mouth but romantic. Mint?
Thank you. Shall I count down from 3?
No, I think it needs to be spontaneous. What do you think?
You propose the experiment. I think you should present your findings first.
Fair enough. On the plus side, it was a good kiss, reasonable technique, no extraneous spittle. On the other hand, no arousal.
None?
None.
Ah. Well, thank you for your time.
Thank you.
None at all?
So, how'd it go with Leslie?
Oh, we tried kissing, but the Earth didn't move. I mean, any more than the 383 miles that it was gonna move anyway.
383 miles. if you recall, we had 18 miles per second. In case you're wondering how many 18s go into 383, it's about 21. So that would imply that they were kissing for 21 seconds. So unless I missed something in the calculations, no. At most, it was 3 times 18, which would be 54 miles. So maybe the Earth was moving 54 miles through space, but not 383. That would take a 20-second kiss, which is no longer a kiss. So that's where we are at. Just doing the calculations on the old TI-80 Samsung here. So in conclusion, you now know the definition of rotation. That is something that spins about its own axis. That was a terrible spin. You know that the Earth rotates once every day. So this is a day if I were an Earth. Again, not a very good spin. You know the You know the definition of revolution, which is an object that spins around an axis outside of itself. So that would be something like this. Hello. Also not great. Then the Earth. You also know that the Earth revolves once every year. So it revolves around the sun once every year. So if I were the Earth, that would have been a year of me getting back to the same spot. Another way to think about that is that location that you're in space right now, you won't be here until a year from now. So that's interesting. We also calculated the speed of the Earth's rotation, which is about 1,000 miles per hour. We calculated the speed of Earth's revolution, which is about 66 to 67,000 miles per hour. And then finally, you can use all this information to fact check things, like things they say on the Big Bang Theory and expect you never to check. You also learned that Earth was a soccer ball, oblate spheroid. Revolution? Rotation. Rotation. So one last question for you. See this record player I got playing right here? The question is it rotating or revolving? I'll see you next time.